We're going to find the volume of a sphere. Turn with me to page 864. Now, in this section, they also have surface areas, but we're just finding volume. But there's a few vocabulary words that we need to know. Recall that a sphere is the set of all points in space that are a given distance from the center of the sphere in space, not in a plane. That's a in. Now, the thing is, though, we can use the same names of things in a sphere that we do in a circle. A radius is a segment that connects the center of the sphere to a point on the sphere. So it's the radius is the same idea. The length of the radius, that's the distance all the points in the sphere are away from the center. Okay? A chord connects 2 points on the sphere. So a chord is a segment that's inside of the sphere. A diameter is a chord that passes through the center. And a tangent line is a line that intersects the sphere in one point only. So radius, chord, diameter, and tangent, I think, mean exactly what you would have assumed if I'd have never pointed these out, wouldn't you? Okay? So the same words have the same meaning. Now, some new stuff. Well, it may not be new. A plane can intersect a sphere in a point or in a circle, or, of course, not at all. If the circle contains the center of the sphere, the intersection is called a great circle. And the end, hear that from geography before? Like the equator is a great circle, the lines of longitude that go all the way around, great circles. The end points of a diameter of a great circle are called poles. North Pole, South Pole. Lines of longitude go all the way around, the great circles. The end points of the diameter going through the center of the Earth would be the North Pole, South Pole. Okay? So here's what this all looks like. If the plane intersects the circle in one point, it'd be like that. It just barely touch it. If it goes through, did I say circle? Intersects the sphere in one point, look like that. If the plane goes through the sphere, your intersection is a circle. I mean, imagine it. Imagine that you've got a sphere right here in front of you, and then you take a slice out of it with a plane. Isn't your cross section going to be a circle? Okay? And if you take that plane, you take that cross section through the center of the sphere, like this one, then you get a great circle. Think of it like the equator. Okay? And what do you call a sphere that's divided into two congruent halves? A hemisphere. Each half is a hemisphere. All right. Now we're ready to find the volume. The volume of a sphere is both very simple and a little bit ugly. It's very simple in that there's only one measurement that matters, and it's the radius. It's a little bit ugly because it's got that 4/3 and a pi in it. You can kind of see the pi coming, right? Since it's circular. All right, the 4/3, that's a little bit of a surprise. So the volume equals 4/3 pi r cubed. 4/3 pi r cubed. The volume of a sphere is 4/3 pi r cubed. Number 5. And since we're not doing surface area, we are skipping around a little bit here. So find the volume of each sphere or hemisphere. All right, this is the easy one. They just flat out tell us what the radius is. So volume equals 4/3 pi r cubed. So that'll be 4/3 pi times 10 cubed. What is 10 cubed? 1,000. 4 times 1,000 is 4,000. So that's 4,000 thirds pi cubic feet for our exact answer. Y'all with me on the 4,000 thirds? Now, when we punch this in to get the estimated answer, you can do it in one step if you use parentheses. Parentheses, 4,000 divided by 3, close the parentheses, times a pi, and there it is. So 4,188.79 cubic feet. Not so bad. Number 6. All right, they're really tricky here. It's a hemisphere. Now, I didn't give you a formula for the volume of a hemisphere. Divided by 2, it's half, right? Okay? Now, they don't give us the radius, they give us the diameter, but if the diameter is 16, the radius is 8. So, when you take the volume, here's the way I like to do it, okay? If it was the whole sphere, it'd be 4/3 pi r cubed. It's half of that. So look, when I multiply 1/2 times 4/3, I would get 8/6, which reduces to 8/6, 4/6, which reduces to 2/3. I mean, duh, isn't half of 4/3 2/3? So I did not write this out as a new formula for you to memorize. I think you can figure it out when you need to. Okay? So 2/3 times pi times 8 cubed. Let's get our exact answer first. 8 cubed is 512. Now, when I multiply 512, well, maybe I'll write it out. You don't have to write all these steps out if you don't want to. That'd be cubic centimeters. But when I multiply 512 times 2/3, 512 times 2, so I get 1,024 thirds pi cubic centimeters. That's the simplified version of our exact answer. So then, let's see what it is as a decimal. So 1024 divided by 3, close the parentheses, pi, and we get 1,072.33 cubic centimeters. So is finding the volume of a hemisphere any more difficult than finding the volume of a sphere? Not really. Number 7. This time they're going to make us work a bit. We're going to find the volume of a hemisphere, and they don't tell us the radius. They also don't tell us the diameter. But they do tell us the circumference of a great circle. Remember what a great circle is? It's what you get when you make a cross section through the center of the sphere. We can use that to get the radius. Okay? So there's a circle that's a cross section of the sphere that goes through the center of the sphere. Its circumference is 24 pi. Don't we know that circumference equals pi times diameter? So if the circumference is 24 pi equals pi times diameter, divide both sides by pi, isn't the diameter 24? All right, now that's the hard part of this problem. So let's stop and digest that. We good? Okay, because it might throw you off for a minute to have to go back to circumference. Okay? All right, once we've got that, we're in business. If the diameter is 24, what's the radius? 12. Go ahead. See if you can finish before I do. Remember, it's a hemisphere. Uh-huh. Did you get the same decimal I got? Did you get the same simplified exact answer that I did? Okay. Notice on my calculator that I didn't do the 1728 times 2 and put it over 3. Look, I knew that was going to simplify. I knew the 3 was going to divide in evenly. I knew it, I knew it, I knew it. I didn't even question it. How did I know it? Because I'm some sort of genius? Actually, I am some sort of genius, some sort. But that's not why I knew it. Because look, doesn't 3 divide into this 12? Well, if 3 divides into 12, it's going to divide into 12 cubed, isn't it? Got to. So I knew it. Okay? All right. Last example. Ooh. Area of a great circle this time. So, all right, we have the same kind of deal here. We need to find the radius. Now, the great circle is the cross section that passes through the center of the sphere. So, I'm tired of using red. So we've got that as our cross section, and we need to find R. We know that area equals pi r squared for a circle. So in this case, the area is 55 pi. So 55 pi equals pi r squared. Divide both sides by pi. 55 equals r squared. So r is the square root of 55. And we know better than to type that into our calculator, don't we? We're going to leave it as the square root of 55. That's the formula for the area of a circle. Okay? And I'm doing that because that's the information they gave me, was area. All right, so far so good. All right, now it's a full sphere this time, so no 1/2. So volume equals 4/3 pi r cubed. So in this case, that's 4/3 pi times the square root of 55 cubed, cubic inches. Now, I'm good with calling that your exact answer, okay? We can simplify that a little bit. That square root of 55 cubed could actually be simplified to, see if this makes sense to you, 55 times the square root of 55. and then I could multiply that 55 by 4. Good enough. This is an exact answer. You don't have to simplify it any further, okay? Because that's the thing about radicals. When you simplify radicals, they don't always look simpler. Because square root of 55 cubed, that's kind of nice and neat, it's compact. Writing it as 55 times the square root of 55 gets kind of drawn out to me. So that's our exact answer. Let's see what the decimal is. So that'll be parentheses, 4/3 times pi times the square root of 55 cubed. Punch that in right, 4/3 pi square root of 55 cubed looks right to me. So we get 1,708.57 cubic inches. All right, any questions? All right, comparing circles and spheres, okay, we don't need to worry about surface area. So it turns out we need to remember how to find the circumference of a circle and the area of a circle to work some of these problems, doesn't it? And you do remember it, okay? And then there's the volume. And there's your assignment. Page 868, 5 through 8, 18 through 25, 33 through 37, 46, 49 through 50, and 52.